Black holes are often described as the monsters of the universe. They are everywhere, scattered throughout every galaxy. But because they emit no light and space itself is black, they are nearly impossible to find in a direct image. This creates a challenge for theoretical physics. If human eyes have never seen one, scientists must prove their existence through data rather than direct observation. We understand the existence of air because we can measure the physical effects of the wind, even though we cannot see the gas molecules themselves. Researchers applied this same logic to the cosmos. They began hunting for the invisible gravitational shadows that high-mass objects cast on their surroundings. Understanding the mechanics of the universe requires moving beyond our visual senses to map the mathematical structures that govern reality. Astronomers locate hidden black holes by scanning for X-ray bursts. They occur when a nearby star is torn apart, sending gas spiraling toward a dense, dark center. This gravitational pull is the extreme physical bending of the universe's structural grid. Spacetime functions like a flexible grid. When an object with enough mass rests on this fabric, it warps the geometry, creating a deep dip. This distortion forces nearby matter to accelerate. Gas falling down this slope heats to millions of degrees, releasing X-rays. Gravity is the physical shape of this fabric. It is the curvature of space and time reacting to the presence of matter. Proving the history of the universe presents a different challenge. Physicists had to find evidence of a Big Bang that occurred 13.8 billion years ago. In 1964, engineers at Bell Labs used this giant horn antenna to measure radio signals. Regardless of where they pointed the device, they detected a constant, low-level background noise. Arno Penzias and Robert Wilson spent many months attempting to eliminate variables. They even scraped pigeon droppings from the inside of the antenna, but the signal persisted. The static was the cosmic microwave background, a ghost-like snapshot of the universe as it appeared 380,000 years after the Big Bang. This 13.8 billion-year-old event is recorded today as an invisible microwave hum that still washes over the Earth from every direction. Beyond space and heat signatures, the most rigid invisible rule is time. We experience it strictly in one direction, from past to future. The block universe theory suggests that past, present, and future coexist as simultaneous frames on a single four-dimensional structure. In this model, every moment in history is a permanent coordinate that cannot be altered. This forward flow is governed by entropy, the continuous increase of disorder. A shattered mug never naturally reassembles because the universe moves toward chaos. This transition began at the Big Bang, which was a state of maximum order. Every event since has added to the total disorder of the cosmos, providing a physical arrow that dictates the sequence of events. Our brains perceive time moving forward because memory itself is a biological process of recording this rising entropy. We remember the past because it represents a state of lower disorder that our neurons have already processed and archived. Human intuition often limits our search for alien life. Astronomers typically look for liquid water, assuming it is the most reliable indicator of habitability. GJ1214b, a massive sub-Neptune exoplanet, initially looked like a perfect candidate. Its mass is estimated to be 70. Without the exchange of minerals and nutrients from the seabed, the water remains chemically isolated and unable to support the evolution of life. The survival of life depends on invisible, delicate balances. To understand the cosmos, we must look past the visible surfaces of distant worlds to find the mechanics hidden beneath.